Hi, everybody. So, just a little bit more about theories for those of you that are in the upper grade levels. So, we already discussed how a theory is a very large established pattern of facts. And we were trying to make it very simple so that you could understand the concept without going into some of the more complex aspects of theories. You see, sometimes the pattern is not perfect. Sometimes there are holes, and we infer what is going on in those holes in establishing the overall pattern that develops the theory. A good theory, however, is going to not only provide a predictive ability for the continuation of the pattern outside of our current human body of knowledge, but also to provide for those inference points as we develop the ability or the technology to see into those points where we inferred the existence of some information. It should validate the information's presence. Also, sometimes there is a bit of confusion between a scientific theory and a scientific law. Gravity is a great example because gravity, there's both. There's the law of gravity, and then there's the theory of gravity. And the law of gravity is pretty much represented by a mathematical equation. Um, I can't remember it exactly at the moment, but it's basically something like the force of gravity is equal to the combined mass of the two objects divided by its distance squared, something like that. But it's mathematical, and it happens every time. If I could measure the mass of the Earth and the mass of this, which I actually can, I can determine the force of gravity, which would be measured by the acceleration due to gravity, between this object and the Earth when I drop it. Okay? The same every time. I can use that same formula to determine the gravitational pull between objects in space, different planets, between galaxies, etc. And so far, it's worked every single time, and that's why it's a law, because it's an observable function, and it happens every time, and it's simple. I mean, I understand that equation may not sound simple, but the fact of the matter is that it's not. There's not too much involved. We don't have to look at a giant pool of factual information to pull together an explanation. It just happens. That's a law. A theory, on the other hand, is an explanation. And there's a theory of gravity, and that theory of gravity explains how mass behaves. And according to the theory of gravity that was expanded upon by Einstein in his theory of general relativity, theory of special relativity, had to do with uh, the nature of gravity as a force between not only matter but also energy. And with his theory, the light should also be affected by gravity. And light has no mass of its own, so it doesn't really work in with the law. However, as we were able to increase our technology to observe the heavens, we have noticed that the predictive nature of his theory turned out to allow for or predict for the bending of light around very heavy objects. So the theory of gravity has been validated through further observation on top of the evidence produced in um, the lab and through everyday observations. Now, another thing about theories is that people view them as being shaky or uncertain. In fact, in some of your books, it makes it very clear that theory is not fact. Well, that's technically true. That's technically true. However, theories are so well established upon fact that they are generally considered as if fact. when analyzing natural phenomena. The changes that theories go through are generally not getting thrown out the door. Hypotheses generally get thrown out the door. New theories that have been validated by some experimentation and are gradually building into larger volumes of evidence can still sometimes get thrown out the door because we find out that the pattern that we're looking at in the facts was really a small piece of a much larger pattern that ended up from a larger viewpoint being quite different. However, generally, long-established theories, and generally enough to be considered the rule, long-established theories don't get overturned. The changes that they go through are more like focusing. So if I'm looking through a pair of binoculars and it's really blurry and I see these green blobs and some big giant brown lines and some circular brown blobs, okay, and then I increase the focus, those things aren't going to go away. They're just going to be more easily seen. As I increase the focus, I'm gradually going to see that the lines with the green blobs are trees and shrubbery. I'm going to see that the round brown blob was a bear or a deer or some kind of animal. And as the focus increases further, I'm going to see that, oh, I'm looking at conifer trees and I'm looking at a deer. And as the focus increases further, I'm going to see, oh, I'm looking at Douglas fir conifers and I'm looking at black-tailed deer. So the overall idea of the theory does not change. It just increases in its detail and complexity. Evolution is one like that, where we have established for a long time that natural selection is a huge driver of evolution. But we now also know that there are some other forces at play, and that the expression of your genotype is not just based upon your genes, but also on your epigenetics. So there's some greater complexities at play there. And the epigenetics, ironically, match one of Darwin's competitors' ideas a little bit more. I think it was Lamarck, on the idea that species acquired characteristics during their life based on need. Essentially, if you had to stretch your neck to get to, leaves a little farther away during your life, then your kids would be born with a slightly stretchier neck. Come to find out, that kind of idea actually does function a little bit, not on the genetic level, but on the epigenetic level, which we'll get into in biology. But the point is that evolution is one of these things that has mountain ranges of evidence in support of it. And it's constantly adding on new components that are helping us to understand the function of evolution. And actually, one of the more recent developments that is just utterly goosebump making amazing is the EvoDevo, evolutionary developmental biology. Amazing stuff. So the theory of evolution has done nothing but get stronger over the years. And it seemingly will continue to. I mean, it's a thing. In fact, we've even witnessed a lot of the things that evolution has predicted, we have since witnessed. We have witnessed the genetic modification over species, transmutation of species in the lab and in the environment. So anyway, just wanted to go into that greater detail on theory. Theory is solid. I should say there are some disciplines where the development of our knowledge is so complicated that the word theory doesn't seem as solid. When you get into psychology and sociology, sometimes you have two or three seemingly competitive theories explaining human behavior. And the reality is that all of these are probably right on target and are very functional. And when we go back to the metaphor of the focusing uh, binoculars, each one of these theories is looking at the same location but from a different direction and seeing something slightly different. The focus hasn't improved enough that all of the competing theories can develop a synchronous relationship in their explanation of the phenomena. So don't think that competing theories means that one must be wrong. That's dichotomous thinking. That's a logical fallacy, something that people fall for a lot. But multiple competing theories usually just means that we're going to develop a unified theory later on. So anyway, thanks for the moment. I'm glad that we could chat, and I'll talk to you later.